My name is Tarnaja, and you're watching Brain Security. We are solving the advent of cyber by TryHackMe, and today is day 19. And the topic is ICS Modbus Clause for Concern. Okay, something totally different for today. Let us get started with the story. The snow falls heavily over Wareville as chaos erupts at TBFC headquarters. What should be the busiest shipping day of the season has turned into a disaster. Another chocolate egg, shouts a frustrated warehouse worker holding up yet another Easter themed package. We're supposed to be shipping Christmas presents. The delivery drones buzz overhead, their mechanical hums sounding almost mocking. Each one returns from its route empty, having successfully delivered its cargo, but the cargo is all wrong. You're called into the command center where screens flicker with delivery statistics. Everything looks normal on the surface. Thousands presents in stock, 98% success rate, and all systems are operational. But the phones won't stop ringing with confused citizens asking why they're receiving chocolate eggs instead of toys and gifts they ordered. The logistics manager pulls up a delivery manifest. Look at this, she says, pointing at the system. The system indicates that we delivered a teddy bear to the Miller family, but they received a chocolate bunny instead. It's the same weight, exact dimensions, but completely different items. Then, on one of the monitoring screens, message flashes for just a second before disappearing. Exploit V6.66, property of Hopsick Island. Why should Christmas have all the fun? King Malhare. Someone has compromised the drone fleet's control system. The attack is sophisticated, falsifying sensor data, manipulating inventory selection, and erasing all traces. This isn't just a prank, it's calculated assault on Christmas itself. Your mission is clear: investigate the TPS drone delivery system, uncover how King Malhare's exploit team has compromised it, and restore Christmas deliveries before Sockmas is ruined. Must be warned, King Malhare doesn't leave systems undefended. Traps are waiting for careless investigator. One wrong move and you might make things much more worse. A mystery discovery? As you walk through the warehouse control room, something catches your eye, a crumpled piece of paper on the floor near the PLC terminal. It looks like someone dropped in a hurry. You picked it, unfolded. Handwriting is hurried, almost frantic. For maintenance use, holding registers, coils, boolean flags, and maintenance tech, December 19. You stare, confusion washing over you. Register map calls. What is this? Terminology is foreign. All of this scribbled in margin, but something about it feels important, like a key you don't know yet how to use. Pocket the note, I'll figure out, and we had a very long story about this. But what exactly does it want us to do? In a nutshell, the entire idea of the story and the room is that we are talking about a mass production like factory and the computer systems used in that. It has various components such as SCADA, PLCs, and Modbus protocol. These are the terminologies that we will get acquainted with before we start with the room. So, what is SCADA? Supervisory control and data acquisition. These are the systems that monitor all your industrial processes. Now, there are a lot of repeated tasks that need to be done in a particular industrial setup, and they need to be done 24 by 7. So a human is replaced by a mechanical machine. But the disadvantage or the drawback of these systems is that they are very old and they were designed in the era where security was not a thing. The trust was already established. There were no hackers or within the internet. So these protocols and terminologies were used back then. But in today's time, it is very easy for a attacker to break into these things because they are old, they don't have security, they don't have authentication. They automatically trusts you. They just listen to what you say and does not ask you who are you to say that. Wow. Second is PLCs, programmable logic controllers. These are the computers that actually handle your actions in the production system. Modbus protocol is the protocol that enables communication between industrial devices. Just like we have HTTP protocol, you can think HTTP protocol is used to communicate over the internet, right? Modbus protocol is used to communicate between two systems, two industrial devices. How to identify system configurations in industrial systems, techniques for safely remediating compromised system, and understanding protection mechanism and trap logic in ICS environments. What is ICS? System responsible for overseeing and conducting functions that support critical infrastructure such as water, power, transportation, and manufacturing. Very different from the systems we use and the softwares we use. These systems, they are not intelligent, they are task driven. You just tell them do this and they will do that, right? Because they just have a mediocre task to complete by a given time. And ICS is the term used in this environment. Now, over here, it says you found this clue, mysterious discovery. It says holding registers, package type selection, 0 for Christmas, 1 for chocolate eggs, and 2 for Easter baskets. Now, over here, the program logic is as simple as this. It is based on the numbers that are given in the registers, or something around that lines. So for 0, you get Christmas gifts. For 1, chocolate this, and for 2, now if you manipulate these things that are pointed with these numbers, you can change how the system works, right? Because the system is just going to take the numeric input and just give you the output that you have told the machine to give. Then we have delivery zone, 1 to 9 normal, 10 is ocean dump. Then is system signature version, default 0, current, you have to check this. Okay. Then we have coils. They are Boolean fact, but first is 0, 1, 0, second is 1, 1. And this is something that tells you about how the system architecture is and what are the components and things like that. And yes, I think first I will go through the tasks that are said and then I will start the machine. SCADA systems are command centers of industrial operations, act as bridge between human operators and machine doing the work. SCADA has nervous system of factory, senses what's happening, process information and sends commands to make things happen. TVS uses SCADA system to oversee its entire drone delivery operation. Without it, operators would have no way to monitor hundreds of drones, manage inventory, etc. The components are sensors and actuators. Sensors detect the stimuli that is present in the human world, and actuators act upon that stimuli. Eyes and hands of system, sensors, your condition, temperature, pressure, position, and weight. Actuators perform physical actions. Motor turns, valves open, robotic arm moves. Then we have PLCs. These are the brains that execute the automation logic. You write the logic that is to be executed by the system. They read sensor data, make decision based on program rules, and PLC decide package weight. If the package weight matches a chocolate egg and the destination is zone 5, loaded into drone 7 will explore PLCs in detail in next task. Monitoring system. Now just allowing the machines to act upon instruction and giving the instructions is not enough. You also need to monitor it. Visual interfaces like CCTV, dashboard, and alarm panels where operations observe physical processes. Security cameras on port 80 show real-time footage on the packaging floor. Okay. These monitoring system provide immediate visual feedback. You can literally watch automation is doing. What automation is doing. Historians, database that store operational data for later analysis. Right. Even just current monitoring is not enough. You also need to save it for later use because what if something goes wrong and you cannot spot it in real time. This historical data helps identify patterns, troubleshoot problems, and incident response scenarios like we have one right now. Then we have SCADA in drone delivery system. We have package type selection. We have delivery zone routing, visual monitoring, inventory verification, and system protection mechanism. And finally, audit logging. Why SCADA systems are targeted? Because they are old, legacy software, default credentials, and they're designed for reliability, not security. As we said earlier, they trust you by default. They control physical processes. If you easily gain access to it, you can actually control the entire operations that are occurring in the particular factory. Protocols like Modbus lack authentication. In 2014, the first ICS OT malware, Frosty Goop, was discovered. Who shall read about it? The malware can directly interface with industrial control systems via the Modbus TCP protocol, enabling arbitrary reads and writes to devices registers over TCP port 502. King Malhare has weaponized these tactics not to cause blackouts but to sabotage Christmas deliveries by directly manipulating the control systems to the Modbus protocol. So much theory. What is port commonly used for Modbus TCP? It is 502. Next, for task 3, we have PLC, Programmable Control Logic, Industrial Computer Design, Control Machinery, Processing Real Environment, unlike laptop and smartphone, these are purpose-built and for extreme reliability and harsh conditions. They don't have fancy UIs and operating systems or updates. They just care about getting things done. They are designed to survive harsh environments, run continuously without failure, execute control logic in real time, and interface directly with physical hardware. Execute control logic in real time, interface directly with the physical hardware. Then we have the Modbus. It is a communication protocol, industrial device used to talk to each other, created in 1979. That is why insecure, and it's one of the oldest and most widely deployed industrial protocols in the world. Think of Modbus as basic request response conversation, client to your computer. PLC, what is the current value of register? Servo, the PLC. Register 0 currently holds the value 1. This simplicity makes Modbus easy to implement and debug, but it also means security was never a consideration. No authentication, encryption, no authorization checking. Then we have Modbus data types for coils, digital output on off, 0 1, motor running, valve open, alarm active, just yes, no values. Discrete inputs on off, button press, door closed, etc. Holding registers, analog outputs from 0 to 65535, temperature set point, motor speed zone selection. Input registers, analog inputs, numbers 65535, current temperature, pressure reading, and flow rate. Distinction between inputs and outputs are important. Calls and holding registers are writable. You can change their values to control the system, and discrete inputs and input registers are read only. They reflect sensor measurements that you observe. Means coils and holding registers can be written onto, and discrete inputs and input registers are only for reading, so they are a bit more secure. In TBS's drone control system, you'll find all of this. Remember that crumble note you found earlier? Now it makes complete sense. Maintenance technicians were documenting these exact Modbus addresses and their meanings. What is Modbus addressing? Each data point has unique address. Think of it like house number on a street. When you want to read or write a specific value, use reference by its address number, right? Because there's a lot of things. How would you reference it? Even in a protocol, right? You do need some kind of pointing thing or some kind of index. So we have Modbus addressing. Critical detail, Modbus address start at 0, not 1. 0 indexing catches many beginner off guards. What documentation mentions register 0? It literally means the first register, not the second. Examples from the TBFC system: holding register, packet step selector, holding register 1, delivery zone, system signature, inventory verification, protection, self-destruct status. Modbus, TCP, and serial Modbus. So much theory. Now you understand how the system works. Mission is yours. Hack it back and save the Christmas. In this task, we'll use Python and the PyModbus library to investigate the system exactly the way King Malhare attacked it, by directly reading and writing Modbus values. Time to see what he actually changed. Let's start. Now I will start the machine. First, now we understand basic concept of ICS and Modbus. We will analyze the compromised TBC drone control system and learn how to safely restore it. First is initial reconnaissance. From the attack terminal, let us run nmap scan to scan for these ports on this host. We begin with reconnaissance. Let's discover what services are running on the target system. First, we will run this nmap command since the machine has loaded now. It says, and we specified port 22, 80, and 502 to speed up the scan, because we are being very specific for these three ports because we know that we only want to check services over here. If you want to perform comprehensive scan for all ports, we use this nmap command. This will take longer, several minutes, as it scans for all the 65,000 ports. Still, it is scanning. Scan is complete. Okay, let us just look over here and see that these three services are running, and key findings are HTTP service, the camera feed that is here, I guess, port 80, yes, and port 502 we have it is Modbus TCP, the PLC communication protocol. Typical of an industrial control system setup, web interface for monitoring and Modbus for programming control. Before diving into technical details, let's see what's physically happening in the warehouse. Navigate to this domain in your browser. Through security camera, you can see warehouse floor in real time. Robotic arms are busy at work and conveyor belts are running smoothly, but something is wrong. Instead of Christmas presents, you see animation. Yes, these packages are filled with eggs, Easter eggs. You see pastel colored chocolate eggs being sorted, Easter theme packaging on the assembly line, delivery drones are loading eggs instead of gifts. Compromised. The status display in the corner shows compromised. Visual confirmation tells you problem is real and active. System isn't broken, it's working, but it is being manipulated. It is a logic manipulation attack. Keep the CCTV feed open in a separate tab. It will update as you make changes to the system, providing real-time feedback on your remediation efforts. Modbus reconnaissance. We'll need to interrogate the Modbus server directly. This is where Python and the PyModbus library becomes essential. Remember that crumbled note we found earlier? Pull it out now. The terminology that seemed foreign, HR0C11 Modbus, is about to make perfect sense. The steps 1 to 5 are optional and you can just read along with them. We have pre-installed it, but if you are using your own machine, you need to ensure you have the necessary library installed. First, you install Python Modbus, the particular library that we will need for doing our task. Then let's connect to PLC's Modbus interface using Python interpreter. Python 3. And step 3, reading holding registers. And read holding register 0 and HR01. There it is. HR0 is set to 1, which means the system is configured to load chocolate eggs. The note was right. This is exactly what's causing the problem. Let's check HR1 delivery zone, and zone 5 is normal. Now let's check HR4, the system signature. The value 66 confirms this system has been compromised by an exploit framework. This matches the taunt message we saw earlier, exploit v6.6s. Reading coils. Coils are Boolean flags that control system behavior. The note mentions several critical coils. Let's read them. Error verification, not disabled C0, and if it falls, disable system not checking stock. Inventory verification disabled, system is blindly following commands without checking if items actually exist in the stock. Means the final checkpoint is being called off, so all these eggs can go out freely. Then we have this is crucial C11 enabled, which means the system is actively monitoring for changes. Remember the warning on the note, never change HR0 whilst C11 true will trigger countdown. Alrighty, let's check the self-destruction. Let's check if the self-destruct is already armed. Good news, the self-destruct isn't armed yet, but it will if we try to change HR0 whilst C11 is active. This is trap mechanism. What is trap mechanism? System mechanism of system program likely related to error handling control flow. In this case, trap mechanism suggests a method used to intercept or handle certain condition states, particularly when modify registers while another condition is active. Means if this condition is active, the HR0 cannot be modified. If you do that, the system will break down. I think that is what they are meaning over here. Technician's warning was trying to save whoever found this note from making things worse. Complete reconnaissance script. Let's create a comprehensive script to see the full system state. Exit the Python interpreter and press Ctrl D, type exit, then create a new file. Let us go to our terminal, create the reconnaissance.py file. Directly, we are going to copy paste the given code and Ctrl O, enter, Ctrl X, save, exit, and run the script. Package type force to X, inventory verification disabled, audit logging disabled. Remediation required. HR0, package type is 1. HR1, this that is already seen. These are the rules, and this is what it has concluded. We are correct. Now a complete picture of compromise. Time to restore the system. Safe remediation. Based on recurrence, we need to disable protection mechanism. That broken thing first, we have to ensure that this is off so that whatever changes we make doesn't break the entire system. Change package after Christmas. HR0 is equals to 0. Currently it is HR0 is 1. Enable inventory certification. C110 means the end check is enabled, and enable audit logging. C13 is true. We read earlier that the bunnies disabled the audit logging so that they cannot be caught. Verify C15 never got armed. We will go to nano restore christmas.py. Paste this entire code. Now we will run this file. Verifying current system state, disabling protection mechanisms, setting packages type to Christmas, enabling inventory verification. Now, after this runs, disconnected from PLC. Also got our flag. Let us see CCTV right now. System restored. King Malhare is upset. What if you triggered the trap? If you had tried to change HR0 before disabling C1, here's what if it would have happened. C15 self-destruct would arm immediately. A 30-second countdown would begin. After 30 seconds, C1 to emergency dump would activate. HR1 would change to 10 ocean zone. All remaining inventory would be dumped. The CCTV would show the trap activation screen. You would need to restart the challenge. This demonstrates why understanding industrial control system before making changes is critical. In real-world scenarios, triggering safety mechanism or traps could have severe physical consequences because whatever command is being modified, it is going to also modify the physical activity. So you need to be very particular about the changes and ensure there is minimum scope of error. More sophisticated because use authenticated Modbus access, manipulated configuration values directly at the protocol, disabled safety mechanism, implemented a trap to prevent easy remediation, left a signature 66 as a calling card. Managers who left the node discovered the compromise was interrupted before they could fix it. Their documentation saved Christmas by warning about the trap mechanism. Congratulations. And finally, we have the flag. The Christmas is saved. Though there was a lot of theory and lot of explanation, it was overall a nice room. Egmas over. And with that, we are done for today's challenge and see you tomorrow.